Here's number 3 from the problems at the back of the packet. It tells us a 3 kilogram block is sliding across a frictionless surface at a speed of 4 meters per second when it collides with a 4 kilogram block that is initially at rest. After the collision, the blocks stick together and slide up a frictionless incline. What is the distance, x, so you can see in the picture, that they will slide up the incline before coming to a stop? Our diagram is already drawn for us, so we don't have to worry about directions here because it's already taken care of. Let's list what we know. If I call this block 1 and this block 2, M1 equals 3 kilograms, V1A equals 4 meters per second, M2 equals 4 kilograms. We know that V2A is 0 since it starts from rest. And we are given the angle of the incline. So this is my phi, is 22 degrees, which means that theta must be 68 degrees. And given all of that, we're looking for the distance it travels, x, or the displacement. We're going to start with momentum because we have a collision happening. So M1 V1A plus M2 V2A. This is an inelastic collision, so equals M1 plus M2 VB. And that's 0. So M1 V1A over M1 plus M2 equals VB. 3 kilograms times 4 meters per second over 3 kilograms plus 4 kilograms equals VB. So this is 12 divided by 7. We get 1.71. Keeps on going. Meters per second equals VB. What did I solve for here? That's the speed of these two blocks once they stick together and start sliding up the incline. So now let's look at what happens once they go up the incline. Just going to redraw a picture. So here's the incline it's sliding up. You've got these two boxes sticking together. They move, and then you're looking for where they're going to come to rest. So they're going to come to rest somewhere up here. Block 1, 2, block 1, 2. And again, they're sticking together, so we can treat that as one object. And this angle was 22 degrees. We know that the velocity here is what we just found, so 1.7 keeps on going, meters per second. And we're trying to figure out the distance it travels. So from here to here, my delta x. What do we know? Well, we know V initial, 1.71 keeps on going, meters per second. We know V final is 0. We don't know any kind of time. We don't know acceleration. We don't know delta x. But let's draw a force diagram for the block as it's going up the incline. So these are from a while ago. Here's my surface. Got weight going down. Normal force is perpendicular. And then no other forces, so we just want to break apart Fg into Fgx and Fgy. Because the block is slowing down, it is accelerating. In this case, it's accelerating down the incline because it's slowing down in the positive direction. And from our force diagram, we know that net force equals right minus left, so 0 minus Fgx. Net force equals mass times acceleration, so this equals a negative mg cosine theta. Masses cancel, so acceleration equals negative g cosine theta. So if I make this a given for this part of the problem, we have V initial, V final. We also know what acceleration is. Acceleration is negative g cosine theta. So let's use the no time equation. We don't have time, we don't need it. So V final squared equals V initial squared plus 2a delta x. Box comes to rest, the two blocks together come to rest at the top of the incline. So negative VI squared over 2A is going to give me my delta X. Negative 1.7 keeps on going, meters per second squared, over 2 times negative G cosine theta equals delta X. The negatives cancel out, we're left with a positive. The box is moving in the positive direction, so delta X should be positive. This number will come out to 0.400, keeps on going, meters for delta X. Only one sig fig, so delta X is approximately 0.4 meters. So this problem combined kinematics, forces, and momentum, which is completely fair game since you have learned everything here. It's just a matter of figuring out how to apply all of them. No time equation. So V final squared equals V initial squared plus 2A delta X, that goes to 0. Negative V initial squared over 2A equals delta X. So negative 1.71 keeps on going, this is squared, meters per second squared over 2, my G is 9.8, times the cosine of 68 degrees equals delta X.